Welcome back to the Leetcode Blind 75 solution series, where we'll be solving every blind 75 solution with Rust. We'll be going from top to bottom on the list at neatcode.io. So today we'll be looking at problem 2, which is valid anagram. And the question says, given two strings S and T, return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all original letters exactly once. Okay, and here we have an example. It says S equals anagram, T equals to nagaram. This is true. Rat and car is false. So, I mean, at first glance, this looks like the reverse, but it's not actually. They just changed some positions. Okay. So as always, I hope you have your VS Code set up um for Leetcode. All you need is this unit struct solution and a main function that that can basically be empty. So let's begin. So the first way I'd like us to think about solving this problem is we have two strings. Let's just write it out. So let's assume the first string is string, and let's assume the first string is string, 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 and the second string is also, let's say, string. Okay, so in order to solve this, first we go to the first string, to the first letter, and then we can use this string as our main and this as our comparer. So let's do this one more time. Let's write string here, and let's write string here. Okay, so we go here and we say, okay, the first letter is S. We go through this array, this entire string, and we look for an S. If we see an S, we remove it and we go to the next letter. So the next letter is a T. We see a T, we remove it, and then we go to the next letter, R. We see an R, and we just keep doing this over and over again till we are done with this whole string. And if at any point we cannot find a letter in this string, we should return false. False. Okay. So that's how I'd like us to tackle this for a start. Although it would be rather inefficient, we'll get into how to write a faster solution in the next example. So let's do this. So firstly, if they are not of the same length, we already know that they can't be a valid anagram if they are not of the same length. So we can quickly check for that. It's s.len is not equal to t.len. Then we simply return false. Okay, so now let's move to the actual solution that we just discussed. So firstly, we say for I in S, okay, we can say T if let, this is some Rust syntax, if let some P standing for position, or let's call it position. Let's make this more descriptive. Let's say for letter in S, if let some position equals t.iter, t.cars dot position, and then we take the predicate, let's say x equals letter. If we do find such a letter, as we've discussed here, if we find a letter, we should remove it. We should take it out. So we can say t.remove, and then we just get the position. Simple as that. But and then we move on to the next. But if not, so we can, to move on to the next, we say continue. But if we do not find the letter, we just simply return false, because that means this anagram is no longer valid. If, for example, uh, let's take a string, another string, let's say string, and let's call this other one SSRING. Okay, so we come over here, we say the S, we have found the S. And if we come for a T, we go here, no T, no T, no T, no T, no T. This string is not found. And then we can also see clearly that this is not an anagram of this, and so we simply return false. Okay, so that's all, we return false from the entire thing. And now if this for loop completes successfully, we should simply return true. Let's see, immutable variable. Okay, so you say let t equals to let's mute t equal t. Okay, so zero position. So it says S is not a valid iterator, so we change it into cars. So that's to iterate over the characters of the string. Okay, so this should be fine. If we copy just what we need over here, Control C, and then we paste it. Let's see what happens. Run. Okay, this works. Let's submit now. This should work. Okay, good, very good. But as you can see, the runtime is quite poor. It's quite poor. So we could actually do much better. Let's see the the better solution of this. So to do this, we will be using the very famous HashMap to make this faster. So what we can do is we create a hash map. Let me use this shape. We create a hash map. Sorry. And then let's put maybe a line here. Okay. And now we have, and this hash map will contain the characters. It will hold characters of the letter. So let's say with string is going to be S T R I N G. So it will not hold all this initially. What we actually want is that as we iterate through string, we add any letter we have seen, any letter we have not seen before, we add it into the hash map if it does not already exist. But if it does, we simply increase a number, which would be the what the each element of the hash map is going to be referencing, or coupled with. So a number, for example, let's clear this. Let's clear this. So now let's assume we go to S. We put S inside here. And because we have not seen S before, we then give this a value of 1 and put it inside. Then we are at T. We have not seen T before. We put T inside and give it 1 and go R. So all this should be string, and it should be 1 1 1 1 1 1 1 1 1 1. Okay. But now let's assume we have strings. Let's delete this as well. Now let's assume that the letter is strings. Then we're going to have um STRING. But instead this would be 2 1 1 1 1 1. So you can kind of think of this like a counter for the letter inside the string. So for each letter, it just outputs the value, the number of times the letter appears in the hash map. Okay, now that's good for S. But what are we going to do for T? For T, we will, instead of adding, we subtract. So let's do this. Let's say we're done with S now, and then we go into T, which is also a valid anagram. Let's make T a valid anagram for this illustration. And then we have TSSGNIR. So we go into T, the hash map tells us, oh, T is 1. We subtract this, and then this becomes, where is the size? And then this becomes 0. We go to S, and then S becomes 1. We go to the second S, and then S becomes 0. Wait, sorry. We go to second S, it becomes 0. We go to the G, and then the G becomes 0 as well until NIR. Okay, so now when we check the hash map at the end of every of checking both for S and for T, and if we find that they are all equal to 0, we output true. But if one is a number, maybe 1 or -1 or -3 or 10, we output false. So that is going to be the next solution. I hope that was clear. We go through S, and then we put the number of times they appear in relation to the letter in the hash map. Then we go through T, and instead of adding, we subtract. And at the end, we check if it's all equal to 0. If even 1 is not equal to 0, we just print out false. But if it's all equal, we print out true. Okay, let's implement that. Firstly, we'll be doing this the normal method and then the Rust method. Let's begin. So let's copy the solution. Yes, let's reset, Control C and Control V. Okay, so what are we going to do? Let map equal std collections. That is where you find the hash map in Rust. Collection and hash map. Then we should have a new. Okay, I guess we could also just set the capacity to be the length of S. S dot length. Okay, length. Okay, so this is fine. Now we could do this first. This won't be very efficient because this is going to be O of n, O of 2n, but yeah, just O of n. So for I in S dot cars, we could then do map dot entry I dot or insert 0 start plus 1. So plus equal to 1 rather. So let me explain what's happening here. We have the hash map in Rust has a method called entry, which gives the corresponding keys entry for in-place manipulation, as you can see over here. So if we end up not finding such an entry, we should add the entry and then specify that this should correspond with a value of 0 and then add 1 to it. So it's similar to what I explained earlier. Okay. So it's similar to what I explained earlier. Let's delete. So if we have some strings and then we do find that letter and we don't have that letter in the hash map already, we're just going to make it 0 at first. Okay, Let's make it 0 at first and then add 1 because we're iterating through S. We add 1. Then for T, we're going to make it 0 at first, 0, and then we add 1. And just keep going. But when we go to the second S, we're going to check and see, oh, it's already 1. We add 1 again, which makes it 2. Let's delete this, and we have 2. So, yeah. Then for T, we subtract instead of adding. So let's do that. Plus 1, and then we can say for I in T dot cars, do the same thing. Map dot entry I dot or insert 0 minus equal 1. Okay, so firstly we should also, if s dot length is not equal to t dot length, return false. Because as I said earlier, if they are not of the same length, then they are definitely not anagrams of each other. Okay, so now we have to check if they're all equal to 0, which is the final step. Map dot, so we have map dot into values. Okay, so this is going to help us iterate into the values. So in the map we have keys and we have values. So into values gives us a kind of iterator over just the values. So into values dot all, and we can say x equals 0. So yes, this will return true or false. This all will check for all the elements. If even 1 is not equal to 0, to return false, else it will return true. That's exactly what we want. There is no need for us to type the return since we are not using the semicolon at the end. So it seems, that's okay. Since we have a bit of an issue. Okay, mutable. So let's make this mutable, and then let's also specify the type. This is going to be a hash map of type card, and then I32. Okay, so I guess we're good. Let's actually, so yeah, this is fine. This is fine. Let's submit this. This is not the Rust way. In the next sample, we will be doing this the Rust way. Let's see. Cannot find type hash map. Okay, I'm sorry. I should have specified from here. Or we could also just import it at the top, but let's do that. Let's use std collections hash map, and then we can now specify. We can specify here that it's just a hash map. Okay. So let's see. Okay, this works fine. This works fine. Now let's go to the Rust way. How to do this the Rust way. So, and how do we do this the Rust way? Now, firstly, instead of using for loops, we'll be using iterators. That is the first change we will be making. So we can say s dot cars. Now this returns an iterator over the characters of s like we discussed earlier. And now dot zip. This is an interesting method. It lets us pair two iterators or two elements, should I call it elements, or values of an iterator into a tuple. So a tuple in Rust is like a compound type. It's a sum type. So we can have like maybe a let tuple of type car I32 u size and bool. So we can just pair them up, and then whenever you are maybe writing to this tuple, you'd say, okay, let it be equal to, this has to be a car C, This has to be an I32, 32. This has to be a U size 300, and this has to be a bool. And let's make this false. Yeah. So that's basically what this is. It just lets us, combine values as one. Now, zip would return a tuple, and this tuple will have the elements of both iterators. And the second iterator we'll be zipping this with is the characters of T. So I hope that made sense to you. We iterate over the characters of S, and then we zip it together with the characters of T. So this helps with efficiency because it's like we're doing this for loop at the same time. So it's like combining these two for loops into one, into one. So yeah, it's sort of like doing this. It's sort of like doing this. Okay, so as a cars dot zip dot all, no dot all, no, dot for each, yes, and then we specify what we would like. So if I press Control Alt, you can see some types. Let me just let's say X, and let's put an empty closure. And let's Control Alt. You can see it gives us an iterator of tuples of car and car. Since this is a car type, this is also a car type. So it gives us car and car. Let's double click to insert that. Okay. So we can now even specify that we want it to be X and we want it to be Y of type car and car. Now, we do exactly this into this loop, but we change a few things. This should be X, no, X, and this should be Y. Let's see. Okay, everything is good. So this is how to do this the Rust way. Now let me explain once again. We iterate over the characters of S, which is a string. We iterate over the letters, and then we zip it up with a T, with the iterator over the letters of T. And then for each iteration, the values inside the tuple which we received from the zip, we will just add to the hash map for the first and subtract for the hash map for the second. I am not too sure which is for S and which is for T, but that should still be fine. That should still be fine. It should not cause any issues. And let us copy this. Okay, copy. Let me see. Copy this, and let's import this. Since this is from the standard library, you can just use it like that. Oh no. So let's run, and we should be good. Let's see. Okay, let's submit this. Yeah, you can see 3 ms. This is much better. So that would be it for this video. I hope you learned well about this solution and the iterators in Rust. The zip method is very, very handy. Yeah, see you in the next one.